Hey everybody, I'm just going to post a quick supplementary video here. It's possible you may run into a question in either the quizzes or the test that uses, instead of a supply or demand schedule and a supply and demand curve, you may sometimes run into situations where the supply curve or the demand curve are being described as an algebra equation. So this would be an algebra equation to describe the demand curve, and this would be an algebra equation to describe the supply curve. So I just want to explain this for you because I don't know that this is in the current textbook. Um, what we're doing here, if we describe the if we describe the curve through an equation, we're saying that the price is going to be equal to a $900 starting point, and then subtracting $15 for every additional quantity that's being demanded. So what we're really describing is the slope, oop, there, just making my axes. We're describing the slope of this downward sloping demand curve. And what we're saying is that if we have a starting price of 900, for every additional unit we add, 1, 2, 3, 4, and so on, that price will decrease by $15. So that's the theory of it. It's simply describing the overall slope of the curve. And the same is true on the supply curve. The price starts at $200, and then for every unit supplied, the price would need to go up by $20. So I have an upward sloping supply curve. It starts here at 200, and then if I added 1 unit, that price would need to become 220. Why? Because I'm adding $20 for that extra unit. So this is the theory of it, just describing the slopes. And I just want to show you how to kind of work with these equations to solve for different quantities, different prices at different quantities, and also for how to solve for equilibrium on these types of equations. So if I want to solve for, I'm just going to go to a blue font. There we go. So if I want to solve for question number 1 here, what is the price at which the quantity demanded is equal to 10? So I have 10 units being demanded. We'll underline that. That's the quantity demanded, and I've given an equation to solve for that. So price is equal to $900 minus $15 for every unit demanded, and here we're demanding a quantity of 10 units, and I can solve this quite easily. So price is equal to 900 minus 15 times 10, which is 150. Price is equal to $750. Okay. So simple enough. At a quantity of 10 units demanded, the price would be $750. We always have to put our statements in our word problems. And we can do the same thing for the quantity supply curve. At what price would the quantity supplied be equal to 5? Right? So once again, I'm just going to substitute. So the price is equal to 200 plus 20 times the quantity supplied. The quantity supplied is 5 units. So price is equal to 200 plus 20 times 5, which equals 100. Price equals 300. I'll put my little dollar sign there. Right? So therefore, I should actually write therefore, at a price of $300, the quantity supplied be 5 units. Said the same thing, I've just kind of said it a little bit differently. So I've created my conclusion, and I've been able to solve for the relationship between price and quantity using just the equations. The slightly harder part is determining the answer to this question. What is the equilibrium price? And I'm given these 2 equations to help me sort through that. I'm going to copy those and bring them down here. How would I determine the equilibrium price? Well, here's where we're going to do a little bit of substitution. So I'm given an equation for the slope of the demand curve. I'm given an equation for the slope of the supply curve. And because these are both equal to price, they have to both be equal to each other as well. So it's going to be true that $900 minus $15 for every unit demanded is also equal to $200 plus $20 times every unit supplied. How do I know that's true? Because they're both equal to price. So these two equations are equal to one another. But I still can't solve this because I have two unknown variables. Right? I don't know the quantity supplied, I don't know the quantity demanded. But I do have an advantage because I know that at equilibrium, which is what I'm trying to solve for, those two quantities are going to be the same. So quantity demanded is also going to be the same as quantity supplied. So whatever that number is, it will be the same number. So I'm actually just going to substitute. I'm going to say let x, I'll use an x here, equal the equilibrium quantity supplied and quantity demanded. So I'm going to take my equation here, and instead of saying 15 quantity demanded, I'm going to say 15x, because that equals the quantity demanded. Instead of saying 20 times quantity supplied, I'm going to say 20x, because x equals the quantity supplied. And now I'm in a position where I can solve this equation quite easily. So I'm going to kind of skip the steps here a bit. If you're not sure how to solve these types of equations, this is Math 1052. If you need a little bit of help with this, come to the drop-in or just send me an email. I'm happy to kind of go through it step by step. But what I'm going to do is move the numbers, the whole numbers to both one side, and I'm going to move the x variables to one side, 20x plus 15x, and I'm left with $700 is equal to 35x. And then to solve for x, which is the equilibrium quantity, I'll divide both sides by 35, and I get 20 is equal to x. So now I have x. X, which is the equilibrium quantity, and the equilibrium quantity is 20. So 20 units, let me scroll up a bit here, the equilibrium quantity is equals 20 units. There we go. Okay, so I've solved for equilibrium quantity. Right? So the only thing I need to solve for now is the equilibrium price. And fortunately, I can do that using either of these two equations. Here, I'm going to have to move this down because I kind of ran out of room. So let's go down to page 2. So I know the equilibrium quantity is 20 units. I have my two original equations. I can use either of these to solve for that equilibrium price. So the price at 20 units, just think back to question 1, is equal to 900 minus 15 times 20, P 900 minus 300, P equals 600. The equilibrium price must be $600. Why? Because I know that the equilibrium quantity is 20 units, and I can calculate the price at 20 units. I can also use the supply curve. I can say price is equal to 200 plus 20 times the equilibrium quantity of 20 units. Price is equal to 200 plus 400. Price is equal to $600. And this is a good check as well. You should get the same answer for both of these equations because all we're doing is substituting 20 units into either of them and finding where they are intersecting on the slope. So now I know my equilibrium price. Equilibrium price is $600, and the equilibrium quantity is 20 units. All right, and so that's it. It's a fairly straightforward algebraic problem set. The only real difficulty would just be remembering this step, where if you're solving for equilibrium, you want to equalize the quantity demanded and the quantity supplied. So you want to say that those are equal to one another. So we'll just use a whole different variable. We'll use X or a capital Q or anything you like. But we just want to say that those two are going to be the exact same thing. So I don't need to say QD and QS. I can just say X for both of them. So there's some additional problem sets that are uploaded to chapter 3. If you want to have a look, try some more. If you need any additional help, like I say, come to the drop-in. Send me an email. Happy to help. Thanks, guys.